All right, greetings everyone. This is the first part of the video for section 5.1. Just so you know, as you go through these, every video will start with a meme like this. It's something I like to start all of my classes in person with, but since we're not meeting in person right now, this is my way to also inject that into the course. Okay, so we're going to start off by reviewing the distance formula, which regardless of which class you took before this one, you most likely have encountered this at some point in your mathematical career. And recall that the distance formula is something that allows us to find the length between 2 points given in two-dimensional space. Now, most people, when they encounter the distance formula, the form that they know of it is d equals the square root of, and then we do this x2 minus x1 squared plus y2 minus y1 squared, and that's all under the root. And as you can imagine, these values x sub 2, x sub 1, y sub 2, and y sub 1, they come from the points between which we're trying to find the distance. So for example, over here on the right-hand side, of the slide, notice that we have 2 points. So we have the point 1, 2 here and the point 5, 5 here. And so we can use the distance formula to help us find the length between those 2 points. Now, in order to use the formula, we need to pick one of these sets of points to be x2 and y2, and one set of points to be x1 and y1. Now, it turns out that it doesn't matter which one we choose to be which, but here is what's important. If I choose the point 1, 2, so that the value for 1 is x sub 1, then the value for 2 must be y sub 1. It cannot be x sub 1 comma y sub 2. Okay, so the subscripts need to match. So if I do it this way, then this top point would need to be x sub 2 and y sub 2. And then we can plug those into the formula here. So here we'll do distance equals. As I mentioned here, we have that the point, or the value 5 is the x sub 2, so we'll plug that in for x sub 2 in the formula, minus the value for x sub 1, which is 1 squared, plus the value for y sub 2, which is 5, minus the value for y sub 1, which is 2, and that is also squared. And then we can go through and simplify. So we have our 5 minus 1 there will give us 4 squared, plus our 5 minus 2 there will give us 3 squared. So we have square root of 4 squared plus 3 squared, which would become square root of 16 plus 9, which becomes square root of 25. And then we know that the square root of 25 is 5. Okay, so we know the distance between those 2 points is 5. Now, because that represents a distance, we also need to put units on it. And in this case, because we were not actually given a units, we're not told that these values here represent meters or inches or feet. We'll just call this 5 units. Okay, so that is the distance between the 2 points there. All right, so that's what the distance formula is and how to use it. Now, something you may or may not have thought about before is, where does the distance formula come from? Okay, and so let's discuss this. And it actually relates to another concept you're probably familiar with, which is the Pythagorean theorem. And so you'll hopefully recall that the Pythagorean theorem, the most common form of that is a squared plus b squared equals c squared. Okay, and you may also remember that the Pythagorean theorem relates to what we call right triangles, which means that if we're going to relate it to finding the distance between 2 points, we must be able to relate this to a right triangle somehow. And note we can do that in our picture over here, whereas if I draw a vertical line here horizontal line here and then connect the 2 points along the distance there, notice that that gives us a right triangle. And then the Pythagorean theorem will relate to that. So notice that we can call this horizontal side here A, the vertical side B, and then the distance we're looking for, we can call that C, and I'm actually going to put that equals D. That'll be our distance. And again, we see the correspondence between the sides of those triangles and their related parts in the Pythagorean theorem. Okay, now I'm also going to re-put in the labels we had for these points before. So this first one was x1, y1, and this top one here was x2, y2. Okay. And let's think about, in terms of x2s and x1s and y2s and y1s, how we could find the lengths of these sides here. Well, looking at the side length A, this one here, one thing I notice is that that length there is 1, 2, 3, 4 units. And that is also the difference in the two x values of those points, right? If I do 5 minus 1, that gives me a length of 4. So it looks like one way to find the value for A would be to do the second x value up there, x2, minus the first value, x sub 1. So we see that the value A is equal to x2 minus x1, so I can plug that in for A over here. So x2 minus x1, that whole thing squared. Similarly, to find the value for B, to find this vertical distance here, we could subtract our two y values. So notice that if we do this 5 here minus this 2 down here, that would give us 3, which is the length of B. And so another way we could write B then is as y2 minus y1. And so this would become plus y2 minus y1 squared equals, and then our value for C, we said that's actually our value for D that represents our distance, so we have D squared. And then notice we can solve for D by taking the square root on both sides. So take a square root here, take a square root of the entire left-hand side. And notice on the right-hand side, the square root and the D squared, those cancel each other out. So we just have a D. And so then we end up with the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and that is where the distance formula comes from. So this also shows that another way to find the distance between 2 points is to actually draw a right triangle surrounding those 2 points and use the Pythagorean theorem is another way that you can come up with it. Okay, that's all for now. Thank you for watching.